Today we will talk about one of the most important subjects related to the oil and the gas industry, which is the column. The column is your main tools to make distillation and fractionation for heavy oils and for lighter component also. The column today we will divide the columns as the general classification into two types: bagged column and trade column. Okay. And for today, we will discuss roughly the main items related to the trade column. Okay, so the function of the tray and the trade column is to facilitate the contact between the vapor phase and liquid phase, so that mass transfer between two phases can take place. So this means that there is a vapor liquid equilibrium on the surface of the tray, and we need to maximize and get the maximum contact between the vapor and the liquid phase smoothly without any troubles. This is the main function of the tray tower. Okay, a physical tray is designed to act as an equilibrium stage. Some part from the vapor will condense on the tray, and the other will leave up toward the top of the tower. A single stage operation versus multi-stage operation. And here we mean by stage the number of trays. So if you are working with tower, this tower is the tray tower as in the photo, and you are work with 10 trays or 12 trays, so this is the equilibrium stage, and you can add as per the calculation of the number of theoretical stage the reboiler and the condenser. Okay, so if you are working with tower, this tower work with 10 actual trays, so the total number of theoretical stages or trays will be plus 2, which is 12. Okay, because you add the condenser and you add the reboiler. Here the absorber, if you are working in amine regeneration, okay, or whatever the kind of absorption happened, maybe the bagged tower will be recommended, and in other or some cases we are work with the trade tower. Okay, but generally related to the absorption, maybe we need to work with the bagged tower. Okay, here I want to discuss with you the main composition of the tray. The tray, which is here in the shape, you will find a weir. This part is a weir, and here is the liquid downcomer. Liquid downcomer to transfer the liquid from stage to stage, from tray to tray. And here is the bubbling area or contacting area. Okay, so you have to focus with me on the main three parts: contacting area, here working with sieve tray or bubble cap tray or valve tray, and here is the weir to make overflow for the liquid. Okay, and here the liquid downcomer. This is to describe the liquid related to the tray. And if we need to describe the gas or the vapor down the tray and go through the holes upward to the top of the tower, which is in pink, which is here in pink color. Okay, the vapor. So you have to understand clearly the liquid behavior and the vapor behavior. The liquid normal behavior is to be here in the top, then through the weir to by the liquid downcomer down. Okay, and here the vapor from bottom to top. What are the main types of the trade tower? Trade tower can be sieve tray, can be valve tray, can be bubble cap tray. Those are the common three types. Okay, those are the common three types. We will discuss in detail. Okay, so tray, opening tray, we will discuss here valve tray, sieve tray, and the bubble cap tray in detail, and make a little comparison between each type. For the type number one, which is sieve tray, the cheapest one, the vapor pass through large number of holes. So this means that the sieve tray working with multi holes here. It's only holes, circular holes, so the vapor can pass easily without resistance upward. This is the sieve tray, okay? And here is the weir, and here is the liquid downcomer. I think the photo is clear. What is the advantage? Simple design and very cheap because it is a summation of holes, okay? And no mechanical movement parts. This is for the sieve tray. Here it's very easy to know that if you have a liquid load, higher liquid load, this load can go down in the wrong direction by going down from the vapor place here, okay, and the tray is weaving or something like that. Clear? Because it's only simple holes. There is no liquid seal, and it is the passage of the vapor that effectively prevents the loss of liquid through the sieve. Disadvantage weaving. What we mean by weaving? This is mean that you have a higher liquid load, the tower flooding or something like that. So the liquid load on the tray is high. So that it start to weep from the holes of the tray. Weaving can occur at low vapor pressure. The vapor load here going up is very low. So this will let the liquid not to go from the overflow liquid downcomer, but from the sieve itself. The liquid height on the tray exceed the tray pressure drop. Okay, this is one of the famous problem related to the sieve tray, and you have to remember all time that the sieve tray, the cheapest one, the cheapest type. Okay, so we will simplify this data as the following. This is the chart, simple holes, liquid downcomer, and here is the weir. What is the advantage? Simple design, cost effective and versatile for many processes, okay? And the disadvantage here is limited vapor liquid contact. Why? Because the liquid vapor contact not organized, it's only holes, okay? Less efficient for some kind of separation, okay? So you consider the simplicity and the cost effectiveness for the sieve tray tower, okay? Okay. Valve tray, this is the item number 2. Valve tray. Here a valve tray is a flat perforated plate with each perforation fitted with a movable disc. This is a movable disc. This is a movable disc, and for this reason it's work with hook, something like hook. Okay, so it's go up and down with the vapor load. It's a little bit controlling the vapor load, not like the sieve tray. Okay, so this why we named a valve tray, because the movement of this hook up and down with the vapor load. So from this drawing we can see this hook, okay, and the movement here up and down, and the vapor go in this pass, and if the liquid load is higher it will close, so hardly it will weep, not like the sieve one, okay, because if the liquid load is higher it will close all these valves like in this position, so the valve will move up or down in response to changing the vapor load and the vapor flow rate. At a normal flow, the valve is roughly in a middle position. At low vapor rate, the vapor rate is very low, the disc settle over the perforation and cover it and close it, okay? So no weaving will happen. I think it's clear now. Why no weaving will happen? At low vapor load. As the vapor load increased, it will open like in this position, so high, and the vapor will go through this nozzle upward to the top of the column. But if the vapor load increased too much, like streaming steam with huge amount or something like that, it will remove the disc from its place. You will receive the disc at the strainer of the pump, okay? So be careful from increasing the vapor load when you are working with valve tray type. The perforation and the disc may be circular or rectangular, like in the shape. The disc valve are the movable component, and I think the idea of working for the valve tray is simple now. This is the normal position, if you are working with low vapor pressure, if you are working with high vapor pressure. Okay, we need to summarize the valve tray as the following: advantage: enhance the mass transfer efficiency and improve the liquid vapor contact. Disadvantage: higher cost and complexity, and maybe maintenance for the moving parts, as we said, hook and go up and down. Okay, maybe the cost of maintenance. Crucial vapor liquid contact, and consider the movable part for increasing efficiency, not like the previous type, which is C1. Okay, the bubble cap tray, which is the most famous. I think all the people working in the refinery and the gas plant know the bubble cap tray. How the bubble cap tray work? Okay, here no hook. This only riser, and with the riser there is some point for the vapor escaping here. So it's a little bit organized more than this is the riser. Okay, this is the riser here, and the path of the vapor is like the arrow here. So it will go up and more organized in the shape and the load of the vapor in comparison to the other previous types. Okay, this is the bubble cap distributed along the tray itself and very simple. What is the advantage and the disadvantage? Here we need to clear that there is a riser and many holes. Here is the direction of the vapor, and for the liquid it's very hard to go through this riser and to go down. So rarely to face a case like weaving in the bubble cap tray. When I'm talking to you about weaving or something like that, it hardly can find in the bubble cap tray. Why? Because there is a riser and the cap, and this cap will close if you are working with low vapor load. The design not rely on the velocity of the upcoming vapor to hold the liquid on the tray. Okay, bubble cap tray disadvantage: high cost. Consider the high cost. The capital cost for installing the bubble cap is higher in comparison to the previous two types, and the complexity through the maintenance activity especially. The advantage: many. Why? Use where very low vapor rate, you have working with low vapor rate through the tower. Adequate resistance time is necessary for separation and chemical reactions. A positive liquid seal is essential at all flow rate. We need to summarize. Okay, the bubble cap. This is the feature. This is the movement of the vapor, and this is the riser and the cap. And we have advantage: excellent vapor liquid contact, excellent vapor liquid equilibrium on the surface of the tray, suitable for high capacity operation also. But the disadvantage is higher cost and the complexity, challenging during the maintenance. Okay, so the application in the refinery and the large scale processes, and this is the previous description of the bubble cap as we mentioned. Is there a consideration when you are installing this tray and designing this tray? Yes, the spacing, the sizing, the layout, the material, and the main ways, and the operation, delta B, maintenance cost, and we will mention the summary. Let's go step by step. The sizing. The tray manufacturer have their own sizing handbook. So there is a standard for the sizing. What is the vapor load? What is the liquid load? And you calculate the number of the trays. Then there is a standard to size the material, model of construction, and the base diameter. Very important, okay? Height and diameter. Tray consideration, the layout, cross flow or normal flow. As we see here is the cross flow. Okay, the cross flow tray is the most commonly used, simple design and economic in construction. Okay, maybe two bars or one bars. Okay, the tray consideration, material for sure. Why the material? Because of corrosion. It's very famous in the refinery, in the gas plant. Many types you can find, like 304 or 316 or 410. The main factor affecting the choice of material of the construction of the tray are compatibility with the chemical processed, corrosive, not corrosive, something like that, compatibility with the column material itself, of construction and anticipated rate of corrosion. Okay, what you expect the rate of the corrosion, and the procedure and expected frequency of cleaning, and the cost itself, cost of the material. Okay, so the next is the Trayman way. What is the use of the Trayman way? Because when I'm tell any engineer in the site, look how many manways in the column, he consider for sure the manway which is in the surface. But for each tray, for each equilibrium stage, you have a manway, and this one manway considered for cleaning and for inspection. And here there is a standard for the minimum size, which is 16-20 inch for each manway. Okay, this is the manway for each equilibrium stage or for each tray. Tray consideration operating range. This refers to the range of the vapor and the liquid rate over the surface of the tray, and the ratio of the highest to the lowest flow rate is often referred to the turn down ratio. This tray will work with the turn down ratio or not. For sure, the pressure drop. And there is a famous question: what is the more compatible with the vacuum processes, the tray tower or the bagged tower? Don't be rush. It is the bagged tower. Why bagged tower? Because the tray tower enhance a liquid level for each tray and increase the delta B. For the vacuum operation, you need to make it easier to make suction for the vapors going up through the column. So it's recommended to use easier, no delta V, easier pressure difference, which is the bagged column. Preferred the bagged column in the vacuum applications. Maintenance, here you have to consider if you are working with a dirty liquid or something like that, the type of the tray itself. The sieve tray are the easiest to clean. I think this is very clear. Tray consideration cost. Bubble cap are the most expensive one. If you are working in a new project and there is a budget issue and you can do the process with sieve tray or valve tray, you can reduce this budget by recommended the sieve tray or valve tray after make all the engineering and the design condition related to this issue. Okay, but you have to know that the bubble cap are the most expensive. Okay, due to its simple design, sieve tray are normally cheapest. I think it's clear. Tray type consideration summary. As we said, sieve tray are cheapest and are satisfactory for the most application. Valve tray should be considered if specified turn down ratio cannot be met with the sieve tray. Okay, and the bubble cap should only be used where very low rate have to be handled and positive liquid seal is essential at the flow rate. Okay, here we will discuss another item related to the tower, which is the bubbling area. What we mean by the bubbling area? The area between the weir and the end of the tray. This is the bubbling area or contacting area between the vapor and the liquid. And here you can face the foaming problem. If you are working with the amine regeneration, you know that the vapor going up maybe carry little bit amount of hydrocarbon. So when it start to contact the liquid on the surface of the tray, it start to make foaming or something like that. And you discover this criteria or issue by the delta B installed on the tower. Okay, as we mentioned before, the contact area, here he want to clear that there is something related to the design, which is the distance between each stage and each tray. Why? Because it should be enough not to carry any liquid above to the next tray. Okay, this is the area or the distance between each tray. What is the weir and what is the weir type? The weir is the end of this area. Okay, this is the weir, and overflow to the liquid down camera start. I think it's clear. The weir will maintain desired liquid level on the tray. This is the function. Typical weir height is between 2 to 4 inch. As you can see, low weir are frequently used in low pressure or vacuum column. Low weir because you don't want to hold a huge amount of liquid. I think also it's clear. The notched type weir are commonly used for low liquid load. This is the notched type. There is a notch here, maybe organized or in this shape. Okay, so we know what is the weir, what is the type of weir, notched or normal, and the function, and what will happen if we increase the elevation or decrease this elevation. Okay. The downcomer is normally the normal path for the liquid from up to down the column. Okay, and there is some design like slope downcomer and some issue related to the design like straight downcomer, segmental, vertical downcomer, widely used as to provide good utilization of the column area, to use all the column area and make this overflow safely and consider the distance between tree and the other. And there is some, in some cases, slope downcomer, slope with slope like that. Vapor liquid disengagement is difficult due to foaming or something like that, so it's recommended to make the liquid downcomer not straight from up to down but with slope like that. Okay, downcomer must be sufficiently large to allow the liquid to flow smoothly from top to bottom. Sufficient time must also be provided in the downcomer to allow proper vapor disengagement happen. Okay, and inadequate downcomer area will lead to a downcomer choking, whereby liquid back up and the downcomer into the tray above and eventually flood the column and cause flooding. This is the normal downcomer. Overflow the weir. This is a normal pass or passage for the liquid of your tower. Finally, I want to appreciate good listening. I hope this lecture is easy and amuse all of you and they supply you with a new information. And finally, appreciate it.